Hi guys.
Yeah, I think Raneet is here. Awesome.
Hey Renee, how are you?
Hello, am I
Hi.
audible?
Yeah, you're audible. Okay, okay, so see you
Hi
guys.
guys. Hi.
Hey Renee, how are you?
I'm doing good. How about you guys?
I'm doing great. So I guess we could start.
Sure. Yeah. Do you want me to turn on my camera, or is it good if I just keep it off?
It depends on you, but we would prefer to turn on camera. And also, do you want to do you have some work to want to share the screen?
Yeah. I mean, I'll need to share the screen, of course. I don't know whether I have the privileges or not. I guess I do. I
Yeah,
don't
you
know.
could
Let
go
me
ahead share the screen.
let me try anyway. Um, you can see my screen, I guess.
Yeah.
Yeah. Okay. That's fine. Right. Okay.
Okay, cool. Um, so I guess we could start.
Okay. Um, okay then. Hey guys, thanks for having me here. I'm Raneet. I'm a blockchain solutions engineer at Polygon. I joined 5 months back here, and and now I'm here taking a workshop on a decentralized lending protocol, a decentralized pool-based lending protocol, if you may or may not know. So I'm gonna start by giving a brief overview of what this protocol is about, and then I'll proceed to explain the main components and the main actions that a user can perform in this protocol. Following which, I will also walk through some of the important smart contracts that have the logic for this protocol. And if the time permits, I'll also show a demo app, the demo app that we have prepared for this protocol. Okay, I guess I should start sharing my screen again. Just let me know if you can see it. Hello, is my screen visible?
Yeah.
Yeah. Okay. Cool. Right. So let's begin then. Uh, okay. So this is a lending protocol built on Polygon. Uh, what this does is this enables users to deposit or supply their assets to a lending pool and earn interest on that. And these users are, of course, lenders, and these assets which are deposited to the pool serve as a collateral, which will allow borrowers to borrow from the pool. So it goes without saying that you have to deposit something as an asset that which is supported in the pool as a collateral before you can actually borrow from the pool. This is basically the screenshots of how the app looks like. I have it running in my local host over here. You can deposit, you can borrow, and I'll come to this later on in the workshop. Um, so yeah, maybe let's get started with the key components and the actions that you can perform in the protocol. So, right, to begin with, we have an off-chain price oracle as one of our components in the lending pool. And why is this needed? Uh, because an off-chain oracle is needed to fetch the latest price of an asset, since the real-time prices change pretty quickly and rapidly. And it's very crucial. It's quite crucial for a DeFi protocol uh, to have the latest, maybe latest value, or even an approximate latest value of asset that is deposited or is being borrowed, and it basically monitors the sort of health of users' deposited asset. And yeah, it plays a pretty crucial role. So in blockchain, you these price oracles are used quite frequently to get the real-time prices, whether be in stock exchange or any swap-based protocol, or in our case, a liquidity pool-based protocol. Although in this picture we have depicted Chainlink, but in this we use band chains protocol, band chains oracle to get the prices of the assets. Okay, so with this out of the way, let's move on to deposit. Deposit, one of the primary functions that you can perform as a user. You can deposit your assets to the pool and earn interest on it. This workflow basically explains how the deposit action actually works. So before the deposit action kicks in, the first thing that will happen, and this is common for all actions, like whether you're depositing an asset or withdrawing that asset or borrowing from the pool or repaying what you have borrowed into the pool, it will always update the interest rate from the last time, because someone might have borrowed an asset from the pool before you are actually depositing, and that would reflect in the change in the interest rate, and we have to update that interest rate before proceeding to any action. So what it does is basically would fetch the last updated interest rate, and it would calculate the new one, and it would make the changes in the state before proceeding. After that, it just increases the total liquidity in the pool, uh, after which it would mint something known as all tokens. All tokens are basically ERC20 tokens, which would represent a user's share in the pool, that your deposited assets into the pool. Like in Aave, you'll have something like USDC or maybe USDT, something like that. And after that, it would just transfer the underlying the asset into the pool. Pretty straightforward, I guess. Uh, some key things here. How is the total liquidity calculated? It's basically the sum of the total available liquidity and the total borrows. Uh, Total available liquidity is pretty self-explanatory. It's just the liquidity available of the asset which you are depositing or maybe borrowing. And total borrows is again the sum of the borrow amount and the accumulative borrow interest. Uh, what the key thing to infer from here is that as the borrow interest grows over time, the accumulated borrow interest will continue to grow as time with time, and this will reflect a change in total liquidity. The total liquidity will increase, and which also means that the number of all tokens which represent your assets deposited in the pool will claim more of the underlying asset over time, because this is how it is calculated. If you see the equation over here, it just multiplies the deposited amount into the total all tokens divided by total liquidity. So as liquidity grows, all tokens, a particular amount of all tokens will represent more amount of the underlying asset with time, as the interest is accumulated from the borrowers. So yeah, pretty straightforward. You just update the last interest and increase the total liquidity, mint an equivalent number of all tokens, and you're good to go. With and now that you have deposited, um, now is the time you could borrow. Before you can borrow, as I mentioned earlier, you have to deposit some assets into the pool as collateral. Some an asset which is actually supported in the pool. Like you can't deposit anything. Like you can't just mint a dummy ERC20 token and deposit into the pool and make it serve as a collateral. It won't work that way. So yeah. So after that, how does the borrow action work? Not very dissimilar to the previous one. It would always, as I said, always update the interest rate from the last time stamp, from the last time when the interest rate was updated, and then it would check. The protocol would check whether the liquidity available is enough or not, for obvious reasons. Because if it isn't, then you can't, of course, borrow from the pool. And if it is, then you're good to go. What will happen is the it would add the new borrow amount to the total borrows, the borrows that we saw earlier in the deposit in the total liquidity equation. And it will also do is calculate an equivalent number of borrow shares by taking the borrow amount and total borrows into account. How is this calculated? We'll come to it a little shortly. After that, it just transfers the underlying asset to the user, and then I guess you're done. So also, the asset that you are one thing to keep in mind is that an asset that you are depositing into the pool has something known as loan to value attached to it, which would basically represent, if I were to take an example, like if I deposit an asset which is worth about $100 and which has an LTV of supposed 75% or 50%, let's say, then I can only borrow an asset with a limit of $50 if it is 50% or $75, depending on the LTV percentage. And and yeah, it makes sense because I can't, if you think it like this, that if I deposit an asset which is let's say worth $20 in the pool into the pool and try to withdraw $100 an asset worth of $100 from the pool, it won't make much sense. It I mean, the protocol that shouldn't allow it, really. And this won't reflect very well to your account health. And this LTV is taken into account when you calculate the borrow limit over here. It would just multiply the deposit value of the asset in US dollars with the LTV, and just make the summation of all the other assets, like deposit value into asset one, uh, into deposit value of asset one into LTV of asset one, and plus deposit value of asset two into LTV of asset two, and so on and so forth. Uh, yeah, another thing that is taken into account is your account health, which is basically which basically means is whether your borrow value is within the borrow limit or not. In simple terms, if you are whether you are borrowing more than you're supposed to borrow, then if you're borrowing more than you're supposed to borrow, then of course your account is unhealthy, and this whole transaction will revert. Like the protocol will not allow you to borrow if you are borrowing more than your borrow limit. The whole transaction reverts in that case. And yeah. uh, Another thing, I talked about borrow shares. How is that calculated? Well, it just multiplies the borrow amount into total borrow shares and divides it by the total borrows. Just some mathematical stuff over here. Okay, I guess that's the complete uh, overview of borrow. After that, we have another main primary action that a user can perform. If you have deposited your assets and you want to withdraw them, this this these are the steps which come into account. And yeah, so as always, what this will do is it will update the interest rate from the last time. This, as I mentioned earlier, will do for all the actions that are performed. It will always update the interest rate from the last time. And again, it will check whether the total available liquidity is enough or not. If it isn't, then of course you can't withdraw, and if it is, then you're good to go. um, the step 3 would be another check. It will see whether your account health is good after withdrawing or not. And if it isn't, then the transaction will revert for obvious reasons. And if it is, it will just proceed. Let me know if I'm going too fast. Uh, it feels weird because this is like one-way conversation. So this just give me a pointer if I'm going too fast here, or if it is too complicated to understand. Because I'm trying to simplify stuff, but yeah, just let me know. Uh, okay, um, guys, I'm audible, right?
Yeah.
Yeah, okay. This feels pretty
Yeah, I
awkward
know.
because it's like it's like I'm talking to myself, but yeah.
Yeah.
Just
Well,
let me know if I'm going too fast or maybe too slow, or maybe I'm not taking enough pauses in between to for you guys to absorb this, because this can be confusing a little, but I'm trying my best.
sounds good. Sounds good.
All right. Right. Okay. Right. So check that available liquidity. If it is enough, then you check the account health. If it is good, then you calculate the withdraw shares from withdraw amount. Uh, and it will burn the number of all tokens by this number of withdraw shares. How is this withdraw shares calculated? We'll come to that. And then after this, it will just decrease the total liquidity by the withdraw amount, and then just transfer this asset to the user. Okay. Yeah. How is the withdraw shares calculated? Well, this is the equation for this. It multiplies the withdraw amount into total all tokens and divides it by total liquidity. But again, the key thing, the conclusion to draw from here is when as the total liquidity increases over time with the accrued borrow interest, the withdraw shares will be less than and I mean what I mean to say is the same withdrawal amount will equate to less number of withdrawal shares, and that eventually means is that you'll have to burn less number of all tokens um, to claim the same withdrawal amount. Because and that also means that uh, um, if you decide to withdraw all the deposited amount, you'll end up withdrawing more than what was originally deposited, because of course you have accumulated deposit interest. This is how the stuff works. How the interest rate works, we will come to that. That will be the last part of this protocol. Um, okay, so we saw how withdraw works. Now let's have a look at how repaying the assets that you have borrowed works. Yet another workflow, very quite similar to the previous ones. As always, update the interest rate, check whether you have enough assets to pay or not. If you have, then okay, it's great. Otherwise, well, the transaction will revert. Yeah, so the repay amount is again converted to repay shares, and this repay shares will be deducted from the borrow shares that was earlier calculated when you borrowed borrowed that particular asset from the pool. And then, yeah, as I said, it will reduce the borrow shares by the equivalent repay shares, and after that it will repay that particular amount to the pool, and well, that's done, and the procedure is complete. After that, uh, okay, how is the repay shares calculated? Well, you have the repay amount multiplied by total borrow shares divided by total borrows. Again, another mathematical calculation, but the thing to infer from here is, again, as the total borrows increases, as you accumulate more interest over the amount that is borrowed, your repay shares will reduce over time. That means the repay amount will be the repay amount will associate to smaller repay shares, and you'll end up reducing the borrow shares by a less amount of repay shares. And this eventually means that if you repay all of the borrowed amount, you'll end up paying more than you originally borrowed because of the accumulated interest. That pretty straightforward. um yeah, that's with borrow, pretty simple to not too much here. Just convert the repay amount to repay shares and reduce the original borrow shares and transfer that to the lending pool back again. And we keep talking about interest rate. How does this mechanism actually work in this protocol? And here we are. The interest rate is largely dictated by something known as utilization rate, and which is calculated by dividing the total borrow by total liquidity, and which is pretty straightforward, because you basically see that how much an asset is in demand, or how much is it being borrowed, how much is it in demand. A higher utilization rate would mean that uh, the asset is in more demand, and hence it will have a more borrow interest rate. Um, every asset, of course, has a base rate, a base borrow rate, and in this particular protocol, you have two ways of calculating the borrow interest rate, because you take into account the utilization of that particular asset. So there is something known as optimal utilization rate, which in this protocol is set to something, I think 80%. Um, so that means if the particular asset's utilization rate is below 80%, below or equal to 80%, that means it is being normally, it's in pretty like it's in normal demand. Then you'll use this particular slope. There are two slopes which come into account while calculating the borrow interest rate. So when a particular asset's utilization rate is below normal or below optimal, you use this particular formula to calculate the interest rate. And if it is more than 80%, if it crosses the optimal utilization, then you use this particular formula. Now this again might look pretty complicated, but the main objective of this is to protect liquidity in the pool, because you don't want like an overutilized asset to be completely like withdrawn frequently than it should be. So interest rate would increase sharply if the utilization increases beyond a certain point, beyond a certain stage. Yeah. Uh, okay. One final thing: how is the deposit interest rate calculated? It is again borrow interest rate into multiplied by utilization rate, and another thing that you can conclude here is a higher borrow interest rate will equate to a higher deposit interest rate, right? Okay. That was the whole mechanics of this protocol, the main actions that a user can perform, namely deposit, borrow, withdraw, and repay, and how interest rate dynamics work. Okay. I hope that wasn't too complicated to understand, but this is essential uh, to understand, to actually absorb before you read the smart contracts, because these equations, these concepts will make the process of reading and understanding the stuff that is written in the smart contracts understand I mean make a lot easier. Okay. I think we are good to move and take a look at the main smart contracts over here. We have the GitHub account, the GitHub under Polygon Academy. So you can of course take a look. I have the app running over here in my local host. Yeah, uh, these are the particular important contracts. The main one is the lending pool, which of course has all the main actions: the deposit, withdraw, repaying, or borrowing, written over here. Uh, yeah, it's pretty well documented. I'll just run through some of the important functions over here. So you have basically three types of status of the pool, whether it is either it is inactive or it is active or it is closed. What inactive means is this pool has been initialized, but you can't borrow or deposit or perform any action. Active means it is, well, active. You can Users can deposit, borrow, and do other stuff. Closed is basically you can't perform deposit. I guess deposit, you can't perform deposit, and you can't borrow from the pool, from the liquidity pool, but you can certainly repay or withdraw. And basically essentially it is waiting for uh, waiting to be inactive. The pool is waiting to be inactive. After that, we have some events initialized, which are emitted once a certain action is performed. Like over here, you have deposit event. This is emitted once an asset is deposited to the liquidity pool. Similarly, you have borrow, you have repay once you repay the assets that you have borrowed, uh, and finally we have withdraw event. These particular parameters with these particular parameters. We also have liquidate, but we haven't implemented this in the app. Basically, what liquidate does is a liquidator can uh, liquidate an unhealthy account, but that's pretty complicated for this demo. Um, yeah. So moving forward, yeah, this structure has the information regarding a user's data, state a user's pool data, and the pool has all the stores all the pool state, every important information like the pool status or the all tokens and the pool configuration. Every pool when initialized will have a default configuration associated with that. And yeah, so some public variables which will help eventually. Yeah, this modifier, this is what I was talking about. This update pool with interest and timestamp. This modifier always is always executed before any action is performed, whether deposit, withdraw, repay, or borrow. What this does is basically it would fetch the pool's last state from the last timestamp, and it would calculate the interest rate and the borrow interest rate and the cumulative borrow interest rate, and following that it will just update the pool state. So like updating the total reserves or the total borrows and the update and the timestamp. This as I said will be executed before every action. It is very imperative. It's quite imperative because when uh, when you go on to perform an action, it might have something like borrow might have happened from the pool, and that might uh, that will change the interest rate, and you have to update the current state to before proceeding. And yeah, okay, init pool. uh, what this will do is initialize the pool. Just it will deploy the all token contract. So this all token deployer over here, I'll go through it. All token deployer contract creates a new all token depending on the token for which the pool is created, like so. um, the pool's state is initialized, and yeah, that's and the owner of the contract can perform this. Only the owner can perform this. And of course you can modify the pool's state, pool's config, and yeah, some basic setup functions: set users collateral, set price oracle, some getter functions like get pool will fetch all the pool's details, get users pool data. Some helper functions calculate linear interest. This comes into play while calculating the borrow interest, as we saw here. Yeah, some more helper functions. Uh, get total available liquidity, get total liquidity. Uh, just calculate, just subtracts the total available liquidity from the total liquidity. Again, some helper functions I'm looking for. Um yeah, so deposit, one of the actions that we discussed earlier. uh, as always, update pool with the interest, with update the interest, and what this does is basically would fetch the pool's status, do some basic checks, like whether this is active or not, or whether the amount is greater than zero or not. Some basic validity checks. um Pretty well, this code is pretty well documented. You can actually read the comments and understand a whole lot of stuff that we discussed earlier. So yeah, it calculates the share amount from the token and the amount provided, and then it will mint an equivalent number of all tokens to the sender, to the user. who's depositing. Uh, then the third step that is performed is depositing users asset to the liquidity, which is basically this contract, and finally then emit that event that a deposit action has occurred. Like as we discussed, all the steps over here are very well documented in the code as well. It's quite comprehensive and pretty easy to understand, and reading this will make it even easier. Yeah, similar to borrow, we similar to deposit, we have borrow. As always, update this the pool's interest rate and with timestamp. This is the modifier which is executed before this action is performed. It's like a hook that gets executed before the actual function is before we actually proceed to the actual functions. Um, yeah, pretty similar. Just fetch the pool's current state, updated. I mean, sorry, do some validity checks. Um, then it will do is this particular utility function will calculate the borrow share amount from the given token and the token address and the amount. Uh, then it updates the pool state. It will update the total borrows and the total borrow shares, like so. And of course, it then updates the user's state, the user's state where associated with borrow shares. It will just add the current borrow shares with the calculated one, and then just transfer that particular asset to the sender's account. These much amount to the borrower, the message sender being the borrower. And at the very end, as I mentioned, it will check whether the particular account is healthy or not. Like whether if it is borrowing then more than its borrow limit, then the whole transaction will revert. So it's important that you are actually allowed to borrow that much to that particular limit. Otherwise this whole transaction will revert. um, then you have two functions associated with repay. You can either repay by amount, or you can repay by shares. The only difference is in the parameters. You just have you just have to give a number, like the total number of asset, the units that you want to repay, or in the share, or you could just directly give the amount of shares. So the amount of assets, or the amount of share, the amount of tokens, or the amount of shares. What this basically will do is again update the interest rate. It will calculate the share amount from the given asset amount, and internally will call this particular function repay internal. And what repay shares does is something, it just directly calls the repay internal function. So all roads, I mean, both these functions lead to this main internal function. um, as always, just fetch the pool's current state, do the basic validity checks, whether the pool is active, or if it is closed. Only then you can repay, otherwise you can't. If it is inactive, you can't repay. um, then it just calculates the borrow amount from the token and payback shares. Payback shares is basically this variable which gets initialized with this share variable. Then update the pool state, update the user state. Of course, you subtract the repay shares from the borrow shares, and then well transfer the asset from the user's account to the contract, which is our pool. Yeah, so this is repay. um, Likewise we have withdraw, um, pretty similar. Just update the interest rate, fetch the current pool state, and then just do the steps that we discussed. Calculate the withdraw amount from the withdraw shares, burn the equivalent number of all tokens, the all tokens that actually represent your share of liquidity in the pool. And the third step is to transfer that number of tokens, um, from the pool to the withdrawer's account. And of course, it will check at the very end whether after doing all these operations your account is healthy or not, whether you are withdrawing more or maybe borrowing more than you are supposed to. And if you are, then well, the whole you won't be allowed to. And and if it is all right, then well, you have your assets back. um, well, liquidate, this is something that we didn't implement in the app for the sake of simplicity. Just it will just check users account health, and if it is unhealthy, then a liquidator can basically liquidate it. um, these are again some helper functions to uh, to help with the main functions, to help the main functions to calculate some particular stuff. Calculate collateral amount. You can set reserve percentage, like you can actually set a percentage of uh, from the liquidity pool, which from which you can't withdraw, and only the owner can actually, under some well, extraordinary circumstances, but you usually set something like around 5 to 10% of the assets as reserve in the pool. And yeah, I guess this is basically what our main lending pool contract does. Related to the pool is another contract called the pool configuration contract. This holds all the configuration settings related to our pool, to our lending pool. So at the very start, you see this graph uh, explaining how the interest rate behaves with the utilization rate. So we have the optimal utilization rate set at 80%. So below this, the interest rate will follow this particular slope, and if it is overutilized, then you see the interest rate increases sharply. Uh, the main reason being to protect the assets in the pool. Yeah. The constructor to initialize the pool config, a base borrow rate, the base rate at which you can borrow an asset, the two slopes, the collateral percent is basically the LTV, the loan to value figure that I was talking about, the loan to value that is associated with every asset that you deposit, right? So, and liquidation bonus percent, this comes into play when you liquidate an account. So yeah, so some getter functions: get base borrow rate, get collateral percent, just calculate interest rate. This utility function will calculate the interest rate depending upon the utilization rate. It takes two parameters: total borrows and the total liquidity. And what it does is basically calculate the utilization rate depending on the current total borrow and total liquidity, and then it will check whether the utilization rate is greater than the optimal utilization rate. If it is, then follow this particular formula, the one that we discussed while explaining the interest rate dynamics. Otherwise, just use this formula. So yeah, get optimal utilization rate, returns optimal utilization rate. Yeah, our helper function, which will calculate the utilization depending upon the total borrows and total liquidity. Um, okay. Uh, so we have lending pool, default pool configuration. Okay, this is our Oracle contract, which comes into play. Which comes into play when determining the real time price of an asset. So this particular what this main function the function to focus on is here the get asset price. This internally will call the reference basic the reference proxy, actually the standard reference proxy. If you see here, this is basically a proxy contract, an upgradable proxy contract, which points to a certain implementation, which is this one, the standard reference basic. So what this band price oracle will do, it will just send the reference data in pairs, like it's like a base quote pair, where a base is the asset for which you want to fetch the price, and quote is usually US dollars. It is fixed at US dollars, USD. So this could be like Matic USD or Veth USD, something like that. So yeah, this band price oracle will call the standard reference proxies get reference data, and this get reference data. Let me just close this. This get reference data will actually call the get reference data of the implementation contract. So you can think of proxy contracts like a pointer to an implementation contract. So these are like you can always update the implementation contract. So you can actually set a new reference, a new basic, a new standard reference basic, like so. Um, and the standard reference basic will just yeah, it will just return the reference data based on the base quote pair, as I was talking earlier. um okay, these basically comprise of your oracle contracts. um all token is, as I said, is the ERC20 token, which will represent your share in the pool. So just a standard ERC20 token, you can mint, you can burn. Nothing very nothing very quite important to see here. All token deployer is the deployer contract, which actually deploys this all token. So you don't actually deploy all token. This is actually done while initiating the lending pool. So let me point. Yeah, in the init pool, you see this all token deployer. This actually deploys a new instance of all token, depending on the token for which you are creating the pool. And yeah, this create new all token gets called while initializing your lending pool. Yeah, nothing much, nothing quite important to see here. Um, okay, we have still about 10 minutes, I think. So let me just show you how the app looks like over here. So two actions you can perform: deposit or borrow. You can like deposit, like say these are some mock tokens that I have deployed for this demo. Um, let's say you want to deposit a certain asset, you can just select from here. This will notify actually what is the maximum amount you can deposit, and then you can set accordingly. Like if you want to set deposit 25% of the total amount, or 50%, or all of it, depends on you. So let's say I deposit some tokens into the pool. Yeah, oops, yeah. I'll just wait for the transaction to get confirmed, which gets quite which gets confirmed quite quickly. So you see, the state is updated. My wallet balance and my deposit balance get updated. With deposit, you can also withdraw. This will show actually how much you can withdraw. You can withdraw maybe 25% or half of it, or all of it. So on borrow, you could borrow or repay some of it. I have already borrowed some Matic tokens from the pool, so the repay option is enabled automatically. Let's say you want to borrow some of Matic tokens, maybe 50%, and just hit borrow. MetaMask pop-up comes up, and well, you have successfully borrowed from the pool. The status gets updated. Um, so yeah, I think this is it for our workshop. If there is anything that I need to explain more on, please point me to that. You can always read the code over here. It's all on GitHub. Or if you want to read the all the concepts which are explained in the book, you can always go to this particular URL. I guess this will be shared at the end of the workshop, uh, maybe in the description, I guess. So yeah, I think I'm done.
Yeah, and thank you very much, Raneet, for this wonderful introductions. And maybe we have some question for you by the audience.
Okay.
Yeah, so one of the audience asked, is there any like live coding?
Sorry, I didn't get that completely.
Uh,
I didn't get your question completely, is what I mean.
yeah, I saw one of the questions the audience asked is if there is any live coding.
Live coding, like you want me to code this? Okay. Yeah, I mean, you see, this project is, as you see, is pretty extensive. Like the contracts are uh, quite long and complicated to write. So I'm pretty sure if I were to write this from scratch, I would easily cross I mean, the limit. Like, you know. But yeah, you can always see actually read the code and understand it, because this is very well documented. And If you read this, read the book over here, read the doc over here, it will be, the code will be much easier to understand. There are some component, that's some aspects of this project that you might want to see, like this is a React app, so if you want to see how the front end is configured, you can take a look. You can take a look at the, maybe the migrations, how the contracts are actually uh, deployed on the blockchain. So yeah, I mean, coding all of this will take a huge amount of time. So I mean, it will take hours, and then you have to test it and stuff. So I hope I understood the question correctly. Like,
Uh, yeah, I mean, another question. Another question is, do you do live coding sessions in the future?
will we do? Yeah, maybe. But that will, I mean, accordingly, like we can't live code all of this in a single session. Like this will be, of course, that will cross the limit, and like we can certainly do some live coding sessions where we can explain you how to deploy a certain, let's say, an NFT contract or an NFT marketplace on Polygon. And that, I think, that will be more interactive that way. And I understand that, because everyone wants to see actually how this is coded and how this is actually tested and deployed on the blockchain. But we have to also keep in mind the constraints that we have.
Yeah, that's true.
Mhm.
Also, another question is, what do you think is like the advantage to building the DeFi protocol, like lending protocols on Polygon compared to other mainstream chains like Ethereum or Solana? What do you think about the advantage of the Polygon?
So you see, Polygon, as if Polygon is pretty cheap. I mean, the transaction speed is pretty high, and the transaction throughput is pretty high, and the fee is quite cheap when you compare it to Ethereum. Like if you come from an EVM based background, like if you are a developer who has written who writes dApps on Ethereum, then migrating to Polygon is like, it doesn't take much effort, because Polygon is EVM based, and it's quite cheap and very fast. I mean, so when I showed you the demo, you saw how quickly the transactions were getting confirmed. But if you see the current state of like Ethereum, you'll see I mean, the gas fees are like insanely high.
Mhm.
Like a few days back, I saw something around 8,000 GUI transactions for speeding a pending transaction up. So yeah, it's pretty crazy, and it's a like a general advantage. Like what would I say is a general answer to why would one prefer building something on Polygon, and sort of migrating to Polygon from Ethereum, whether it is a DeFi protocol, or you see an NFT marketplace, or any gaming, or any dApp on Polygon. That's a huge advantage that you have, like the transaction throughput and the lower gas fee. Like, it's really cheap.
Yeah, I see.
Mhm.
Okay. Yeah. I think that will be it for today. I don't see any questions coming up. And
Mhm.
thanks for all this audience who asked the questions. And also thank you very much specifically for you for the wonderful presentation today, Reddit. Thank you so much.
Thank you. Thanks for having me, guys. Thanks a lot.
And no problem. I
Um,
think the whole session is being really helpful for all the audience, especially for all the developers who want to do things on the Polygon. Very helpful. And
yeah, I'm glad to be a part of this. So
yeah,
thanks a lot, guys.
definitely. And just for audience, this just for all the audience. Right now, Dora Hacks and Polygon are co-hosting the Polygon-Grants Hackathon, which is the very first global Polygon-centric hackathon, and also the very first Polygon quadratic funding grant when we were using Matic token as the main voting and donation currency. And we are really looking forward for all the new projects building on the Polygon network. And yeah, in the following days, we will have another few workshops for our developers. Tomorrow we are having Prash and Maria from Argo app with us talking about ship your the app to new app. And also welcome you to Reddit if you have time and want to join us.
Sure.
And if you don't want to, if you haven't followed us on YouTube and Bilibili, make sure you do that so you won't miss out any upcoming events and workshops in the future. And I hope you have a great day, Bennett and all the audience. Have a great day, and thank you for joining us today. Thank you, and see you guys soon.
Have a great day, guys. Thanks for joining. I hope you enjoyed this. And of course, just one thing, you can always read, for all the developers, you can always read the code on our Polygon Academy repo. So to have a deeper dive into, maybe I might have, of course I can't explain everything given the constraints. So please you can take a look for yourself and and ask questions.
Yeah, that's amazing. Thank you, René. And
Thanks, guys. Thanks a lot, Lee. Bye bye.